In this project, you're going to be adding joints into your simulation, where joints connect pairs of objects together, very much like your knee connects your lower leg and your upper leg. In this project, you're going to connect the right lower leg to the right upper leg, and when you run your simulation, you should see that those two parts rotate relative to one another, whereas the other parts fall independently of one another. In the second step, you're going to be adding 4 knee joints, so that all of the 4 lower legs and all of the 4 upper legs are connected to one another. In the third step, you'll connect the right upper leg to the main body, and then finally, you'll attach all body parts together, which will give you a total of 8 joints connecting together 9 body parts. In the fifth and final step, you'll put rotational limits on these joints, which means that they can only rotate a certain degree relative to one another. Joints are defined in bullet using the three-dimensional coordinate system. Recall that x is the horizontal axis, y is the vertical axis, and z is the axis that points into and out of the screen. Let's imagine that we have 2 objects that we'd like to connect together with a joint, a red object and a green object. We're going to specify the position where this joint is, which lies at the point where these 2 objects come together. And we then need to tell bullet how these 2 objects should rotate relative to one another. And we do that by defining a vector in three-dimensional space, which is the joint normal. In this example, I'm going to lie the joint normal along the z-axis. And when we do, that joint normal describes a plane which is perpendicular to this vector. In this case, because our vector lies along the z-axis, we're defining the x-y plane, and that's the plane through which these 2 objects are going to rotate. So as these objects now start to fall and roll and move in the physics engine, they will rotate relative to one another through the xy plane. If we want to define 2 objects that rotate relative to one another that rotate through the xz plane, then we would define a joint normal that lies along the y-axis. Finally, we can define joint limits, which will indicate the relative angle through which these objects can rotate relative to one another. So if we define these joint limits, then the objects can only rotate this far upward and this far downward.